I'm going to walk you through how we create a model to figure out what regions of Port Alberni are at risk for inundation during a tsunami. So I'm zoomed in on Port Alberni. I've got this DEM, digital elevation model, and this water bodies layer. And we're going to use these two pieces of information to figure out where might flood during a tsunami. So our specific criteria for now are to identify all the land surfaces that are 5 meters or less above sea level and within a kilometer of the water bodies layer. And so we're going to use a model to do that. Models are great tools for many things. You can string together multiple tasks. They are a good way to visualize your workflow, and they're a good way to repeat your workflow if you either made a mistake or there's some update that you need to make. So to create a model, you just right click and go new model. I will rename this model for the final module that I share with you for the folder. It's going to be called inundation model, but for now I'm just going to leave it as is. So when you create a new model, you're going to get this empty page. You can drag layers over. So we need both the DEM and the water bodies layer in here. And then you can do the same thing with geoprocessing. So we've got 4 steps that we need to do in this model. The first one, we need to reclassify our DEM to identify just the areas that are within the target elevation. So we're going to set, you'll notice when you open these tools within Model Builder, it looks pretty much the same as when you just open it over here, right? But when you open it within Model Builder, the drop down, you have multiple options for the input. These are the table of contents variables, and this are the model variables. So we're going to use the model variable. And we're going to explicitly define our classification scheme. We'll say 0 to 5. We're going to give it a value of 1. And then we will say 5. And then the top value, we're just going to set it to an arbitrarily high value that's above anything in our DEM. So we see 1805 is the highest value. We'll just set it to 2000. The point is to just make sure it's all inclusive. And we'll set this to no data because we want to just get rid of everything that is above the area we care about. So we'll click OK. You notice when you do that, you get these strings of arrows that connect everything together. So then we need to convert this layer to a polygon. So we'll go raster to polygon. Again, you just drag it over. Click the drop down for the inputs. We will go with the reclass PA2. We'll leave everything else the same. And then if you feel like you need to zoom out, you can hit fit to window. If you want it to look nice, you can click auto layout. So we've got 2 more steps to do. We need to buffer our water bodies layer. What the buffer is going to do is tell us all the areas that are within a kilometer of the coastline. So we're going to buffer it. We'll set the water bodies, again, choosing from the model variables as the input. Distance unit, or the distance is going to be 1,000. It should, smart enough to know that it's in meters. Then you click OK. And now I've got 1 more step to do. We're just going to use what's called a clip, right? I introduced that last week, I believe. The clip is just a cookie cutter, if you will. And so with this, it doesn't really matter which layer we set as the input and which we set as the clip feature. In some circumstances, it does. But for this, all we are concerned about is the area covered by both of these layers. We're not really worried about much else. So it doesn't really matter the order in which you do this. In many other circumstances, it will, but we'll just click OK. Auto layout and fit to window 1 last time. And you see that you have this string of processes lined up together. And so each of these is just an intermediate step. We don't need to add them to the map. We're not worried about them. The one we do want to add to the map is this one. This is our inundation layer. So we can right click and select add to display. Now, nothing comes up yet because we haven't run the model. But when you click run, the model will then run through all of the processes, and it will highlight in red as it goes through. It'll tell you when it's done. It'll tell you how long it took. So it took 5 seconds to create this. So you can see how much more efficient this is than doing step-by-step clips, right? So we turn this off, we turn this off, we look at this layer, and we say, okay, these are, according to the model, areas that are within 5 meters above sea level, or below 5 meters, and within a kilometer of the coastline. Now, if you want to see what these intermediary steps look like, you can right click and you can select add to display. And this will also come up on the display. And so you see these are all the areas that are 5 meters or below. You can do the same thing for the buffer. If you click on the output, add to display, you'll see what the buffer looks like, right? So this model is going to serve as the basis for the rest of your lab assignment for Module 5. So we're going to work with this model, use this inundation layer that we've created to identify all the areas that are at risk, right? So you could even give this a better name if you want. You can open the output dialog, change the name, call it inundation zone. Click OK. You want to run it again, it'll rerun the whole model. Just takes a few seconds. Now notice what happens when you leave these add to displays checked, right? It adds all these values that we don't need, right? So you can, generally speaking, just leave the add to display turned off for most things unless you want to inspect it. So I will have you work with this model as a base to get started, edit some of the inputs. You're also going to use the output from this model to create another model of your own to identify the areas that are actually at risk. So, because if you look at this one, just change the symbology real quick to explore it a little bit, you see that this doesn't show too many areas that are actually at risk, but 5 meters is definitely too low of a value to actually set for our threshold. So we're going to use a higher value. So I'll have you all play around with that. And again, one of the nice things about the model is it's really easy. Say you want to up this to 6, change this to 6, run it again with just one little thing tweaked. You can very easily do that. It doesn't take hardly any time at all. Much nicer than having to try to string together all the things that you had done in a point and click fashion, right? And so this is what it looks like if you change the elevation by 1